Hi, I'm Bill Kinney. This is a series on the foundations of arithmetic, algebra, and graphing. It's video number 43. It's part 2 of a sub-series on algebra, formulas, functions, and graphing with an emphasis on spreadsheet usage. We're not getting to the spreadsheets yet. In the first video in this sub-series, we focused on a problem that is a relatively simple problem, I hope you agreed. But I wanted to bring out some themes in it. It's not too hard to solve. You set the cruise control on the highway and go 340 miles in 5 hours. How fast are you going? Turns out to be 68 miles per hour. And how far can you go in 6 hours and 15 minutes, 6.25 hours at the same speed? I solved it with a proportion in the first video to emphasize some algebra skills. But you could have solved this problem without setting up a proportion like this, right here. You could have just realized, well, to figure out how far I'm going to go in 6 hours and 15 minutes, just take the speed, the rate, if you will, and multiply times the time, 6.25 hours. And that gives you the right answer. The right answer was 425 miles. 68 times 6.25, 6 hours and 15 minutes is what that is. 425 miles is the answer. So it's pretty easy to answer this question pretty quickly. But I wanted to set it up as a proportion to emphasize that we can, for one thing. The unknown here was I called y. Y was the number of miles. I can go 340 miles in 5 hours. That's going to be proportional to the ratio y miles in 6.25 hours. We want to solve for y. The key thing being to get rid of the 6.25 on this side so that you have a y isolated. So therefore I multiplied by 6.25 hours. But if I do it to one side, the right side, I have to do it to the other side as well to balance. That's a basic algebra principle. To get y equals 425 miles. But then I generalized it and said, well, what if the number of hours is an unknown as well? Call it x. I could solve this equation for y in terms of x, and that's what I did here. I multiplied both sides of it by x, got this equation, y equals 68 times x, 68x, giving me a formula, a recipe, if you will, telling me if I take x amount of time to drive, take 68 times that x to get y, the distance traveled. This is a formula. Formulas are recipes, just like regular recipes for food, telling you how to make something, if you will. In this case, make the distance traveled when you have something, when you have an amount of time. Formulas define things called functions. This is an example of a function. The word function in math intuitively means essentially a relationship between variables. X and y can both be thought of as variables here. What are variables? Well, they're just quantities that are typically symbolized by symbols like x and y that can take on lots of different values, that can vary, if you will. What I'd like to do now is I'd like to graph this function. So we're going to do a little graphing. So what you want to imagine is the paper or whatever you're writing on as being a plane, a flat surface that goes on forever and ever. And you typically want to draw a couple lines that are perpendicular to each other as well as you can. You typically label the horizontal one here the x-axis, call it x, and you typically label the vertical one here the y-axis. Each point in the plane has what's called coordinates. I don't want to actually literally draw right now because I want to put my graph on here, but I pick any point. It's got coordinates based on the scale that I give the x and y axes. Now you don't have to use the same scale on these axes, and in fact I'm not going to in this problem. Maybe the scale on the x-axis is that 1 inch is going to represent 1 unit. Also, I'll literally do some inches here. My ruler, there's 1 inch, another inch, another one. So that's going to represent 1 unit on the x-axis. X, based on the formula, y equals 68x from the previous piece of paper, is going to represent amount of time. It's good to label this time in hours. So So this is 1 hour, this is 2 hours, this is 3 hours, this is 4 hours along a number line that's horizontal here. 0 hour starts there, where you typically want the 0 to be where those cross. This point right here is called the origin. Y was the distance traveled, distance in miles. I can use a different scale along the y-axis. It's common to maybe use the same scale, but I want to emphasize that you can use a different scale. And so maybe instead of inches, I'll use centimeters here. And I think it will also be useful to do something else, a little strange. Let's see. First, I'll make the marks here. So these are about 1 centimeter apart. The other thing I'm going to do is a little strange unless you get used to it, is instead of labeling these 1, 2, 3, 4, 5, 6, 7, etc., I will label them with other units. I think I'll label them with units of 50, in fact. That's going to be 50, then 100, then 150. These keep just going up by 50. These are distances traveled in your car. All right, I got to do this quickly here. So we've got this equation, y equals 68x. It defines a function relating how does the distance traveled depend on the time that you travel if you are going at 68 miles per hour. What you want to do is you want to make a graph of this, is you want to plot some points. You pick different values for x, which is called the independent variable, like 0, 1, 2, 3, 4 might be good to pick. And then based on that formula, you figure out corresponding values for y by imagining substituting the various values for x in place of the x in the equation there. So when x is 0, I plug in 0 in place of x. I get 68 times 0, which is 0. Y must be 0 as well. When x is 1, I plug in x equals 1 up here and do 68 times 1 to get 68. When x is 2, I plug in 2 in place of x, and the formula says to take 68 times 2 to get what y is. 68 times 2, that's 136. So I put 136 there. Then I do it with 3 and 4. 68 times 3. Let's see, what will that be? 204, I believe. Is that right? I'm not sure. Yes, 204. And then 4 times 68, that's going to be 272. Then I would want to plot points based on this. I want to first plot a point with coordinates 0, 0, which is the origin. That's easy. It's right there. The next point I want to plot is the point with coordinates 168 when x is 1, y is 68. So what that means, hopefully you remember, is you have to go over to where x equals 1, go up, straight up from that until you get to a height of y equals 68, and you have to kind of guess here. Here's 50, 60 would be right around there, 70, a little less than 70, so something right about there is the point with coordinates 1, 68. You can write that if you like, 1, 68. The next point is 2, 136. Go over to 2, and then up to 136. Do your best. 136 might be right about there. Go horizontally over until you're above the 2. There we go. There's the next point. Then 3, 204. 204 is right about there. Go until you're above the 3. And then finally 4, 272. 272 would be right about there. Go over as best you can until you're above the 4. Looks like these points lie in a straight line, and in fact they do. And to emphasize that, I will draw it with a ruler here. The graph here is a straight line. In the next video, we'll talk about how to interpret the meaning of this, and I'll also consider some other examples.